Hi, it's September 11th, 2020. For today's announcements, remember that the Unit 2 Quiz 1 locks out tonight. That's the unequal heating of Earth quiz. Your Unit 1 test retake also locks out tonight. Quiz 2 doesn't lock out till Monday, so you got some time on that one. And that progress reports go home next week. I'm not sure what that looks like. At least while I'm recording this video, I'm not sure what that looks like yet. But we shall see how this progress report thing works, especially for you virtual people. Today's learning targets, we are still recognizing that the sun provides the energy that drives convection within the atmosphere and oceans, producing winds, and hopefully we can identify how global patterns of atmospheric movement influence local weather using weather maps that show high and low pressure and fronts. So we haven't looked at the maps yet. We've seen some of the symbols, but we're going to start reading those maps on Monday or Tuesday of next week. Our task for today, we're going to view this lesson video. We're going to complete vocabulary and notes on page 15 and 16. And then if there's time left, you can use that to fill in any missing latent assignments that are still available. Things like, actually, there's nothing. Now that I think about it, there's nothing left except for your quiz on unequal heating of Earth. So yeah, make sure that that is done because all the Unit 1 stuff is locked out now. We are done. We're not touching that stuff anymore. Okay. So your notebook should look like this, or it doesn't have to look like this. So these are the words that we're going to go over to make sure you understand them and have some idea. Now, how you set those words up in your notebook is completely up to you, but you got those 2 pages to do it. I do not want you to write down the entire long, drawn out, descriptive definition. I want you to write down what you need for you to understand. For some of you, that is doodling and drawing. For some of you, that is, use your shortcuts. Don't write a novel trying to do these definitions. Some of them are just going to be drawings anyway, but just write down what you need for that word to make sense to you and stick in your head. You're putting the definition in your own words helps. Whatever it is you need to do. Now, if you need to write everything down and that's just what you do, hey, have at it. But I'm just telling you, you don't have to. Write down what you need to make sure you understand it. Okay. So our first word, convection. Hopefully we know what convection is by now. It is the motion in a gas or liquid in which the warmer portions rise and the colder portions sink. Now, if I start talking fast, don't forget you can pause the video, okay? You can pause it at any point. Our next word is air pressure. Air pressure is a measure of the weight of air above us in the atmosphere. Air pressure changes with weather. High pressure happens when cold air pushes down, usually bringing fine weather. Low pressure happens when warm air rises up to make clouds and rain. A weather front is a boundary in between 2 masses of air of different densities and is the main cause of significant weather. On weather maps, fronts are depicted using various colored lines and symbols. The air masses separated by a front usually differ in temperature and humidity. A warm front is a boundary between 2 air masses, one cool and the other warm, moving so that the warmer air replaces the cooler air. A cold front is a boundary between 2 air masses, one cold and the other warm, moving so that the colder air replaces the warmer air. A stationary front is characterized by cloudy weather accompanied by light or heavy precipitation. It's going to occur between 2 air masses that more or less don't move, so neither one is strong enough to move the other. Some stationary fronts wobble back and forth for several hundred miles a day, so you get a large area of light prolonged precipitation. The occluded front is a combination of two fronts that form when a cold front catches up and overtakes a warm front. So the occluded front is formed when a slow-moving warm front has entered an area, and then you have a cold front that kind of catches up with it and overtakes it. High pressure systems, they are a whirling mass of cool, dry air that generally brings fair weather and light winds when viewed from above. The winds spiral out of the high pressure center in a clockwise rotation in the northern hemisphere. These bring sunny skies. Remember, high pressure is going to be that cooler, drier air. The cooler air is heavier. So high pressure is heavier air. It's going to bring big, blue, pretty skies. A low pressure system is a whirling mass of warm, moist air that generally brings stormy weather with strong winds when viewed from above. Winds spiral into a low pressure center in a counterclockwise rotation when viewed in the northern hemisphere. A low pressure system is represented as a big red L. Low pressure, lousy weather. The Coriolis effect makes things like planes and currents of air traveling long distances around Earth appear to move at a curve as opposed to a straight line. One of the most important things the Coriolis effect acts on are storm systems. Big storms like hurricanes and typhoons, or tropical cyclones, are low pressure systems. That means they suck air into their center. The air being sucked into the storm deflects. This deflection is what causes tropical cyclones to spin. A hurricane is a large rotating storm with high-speed winds that forms over warm waters in tropical areas. Hurricanes have sustained winds of at least 74 miles per hour and an area of low air pressure in the center called the eye. Warm water fuels hurricanes. When a hurricane forms in the warm tropical ocean waters of the Pacific Ocean, we typically call it a typhoon. A typhoon is a name for a cyclone, a big storm that forms in warm tropical ocean waters of the world. Typhoons occur in western and northern areas of the Pacific Ocean and are storms that rotate or spin around a center called an eye. Density is a measure of mass per volume, how tightly packed the molecules of a substance are. The average density of an object equals its total mass divided by its total volume. In 6th grade, you learned to measure density. And on your STAR test for 8th grade, you are again tested on measuring and calculating density. So D equals M over V. Thermal energy is also called heat energy, and it's produced when a rise in temperature causes atoms and molecules to move faster and collide with each other. The energy that comes from the temperature of the heated substance is called thermal energy. On this slide, you just have some of the basic weather symbols that you will need to know in order to interpret what is happening on the weather maps. So again, we'll go over those a little bit next week. This is a really short unit, so we'll spend the day doing weather maps and answering some questions, making sure you understand how to read a weather map. But here are the symbols, the basic symbols that you'll need to know. A barometer. There we have a digital barometer and then the traditional one there. A barometer is a scientific instrument that is used to measure air pressure in a certain environment. Pressure tendency can forecast short-term changes in the weather. Another tool is the anemometer. An anemometer is a device that is used for measuring wind speed and direction. Again, we have the traditional anemometer there in the center, and then we have the two digital ones on the outside pictures. Psychrometers are used to measure relative humidity in the atmosphere through the use of two thermometers. So there's a dry bulb thermometer that's used to measure temperature by being exposed to the air, and then a wet bulb thermometer, which measures temperature by having the bulb dipped in a liquid. Again, these come in a variety of forms. You have the digital one there, which is actually easier to use than the other two. But we do have the two traditional psychrometers there as well. A convection cell is a system in which a fluid is warmed, loses density, and is forced into a region of greater density. The cycle repeats and a pattern of motion forms. Convection cells in Earth's atmosphere are responsible for the blowing of wind and can be found in a variety of other natural and man made phenomena. You will see convection cells in several units this year. And finally, our last word is humidity. Humidity is the amount of water vapor that is in the air. Because air can hold different amounts of water depending on the temperature, relative humidity is how much water the air is holding compared to its temperature. So you want to know both of those. Just in general, what humidity is, and then what is relative humidity. So, relative humidity is dependent on the temperature of the air.